We want to make if then or let then statements. Now we're going to show, hurry up. So if then or let then statements, that's going to assign your variables to the word problem. So you're going to look at your word problem, and then your variables will be assigned to one of your unknowns. To help you with this, you want to read the last question sentence to help figure out the variables. Now these first ones I'm going to do very formally, and then later on we'll do it very informally. Okay. Often using letters that represent the variables would be the best idea. For example, for ice cream cone, I would use I. For chocolate bar, I'd use the letter C. Okay. For an apple, I'd probably use the letter A. However, X and Y can always be used to represent anything. Okay. So our first question says the sum of two numbers is 162. Their difference is 48. Find the numbers. So the last sentence says find the numbers. That means we want to make our if-then statement based on that. So if X equals the first number, then what should Y equal? The second number. Now our our word problem isn't distinguishing the smaller number and the larger number. So when we do our if-then, we don't have to use larger or smaller number. We can just use one number and other number. Okay. So let's make us look at our first sentence, the first part. The sum. What does sum mean? Addition. Okay, so we're going to add our numbers together. The sum of two numbers is almost 95% of the time will represent your equal sign. So the sum of two numbers, that would be X plus Y, is your equal sign, 162. That's your first sentence in your first math equation. Okay. This unit is all about making equations. If you don't make your equations and you only get your answers by using a calculator, you'll get 1 out of 3. That means you're failing. You must be making equations and solving them. Okay. Good. Their difference. What's difference? What math operation? Subtraction. Now when we do subtraction, which number should we put first? Smaller or the larger? Always the larger. So it should be the larger minus the smaller. Now when we read our sentence, does it say anything about a larger or smaller number? No. So we don't know yet. So when we subtract them, if we go X minus Y, what did we make the larger number? X. And if we go Y minus X, what did we make the larger number? Y. Either of them will work out exactly with the correct answer. Okay. So here we are just going, by putting X first, we make X larger. Good. What does the difference equal? 48. Okay. Let's practice substitution because this is the only question where it's nice and easy. Here, change this to X equals. What is that? Actually, let's change it to Y equals, and Y equals what? 162 minus X. So now we have to go and solve. So we should get X minus what goes in brackets? 162 minus X. Okay. Multiply in. So X minus 162 plus X. 2X equals what? 210. So X equals 105. Now that we know X, let's substitute in and find Y. Okay. So x plus y equals 162. We'll put that number in for x. 105 plus y equals 162. What does y equal? $57. So let's put our answer in a little box or make a little sentence. One number or two numbers are 57 and 105. So now we're not really writing points, but we're using the system's idea to help us find the answers to a problem. Okay? All right. Next one. Read the next next equation. Underline the important stuff. Make up an equation for the very first sentence. Go. So, sum of two numbers is 56. Is your equal sign. The larger exceeds twice the smaller. Now they're specifically saying large and small. So if x is the smaller, and we could have chosen it to be larger, it doesn't matter. We have to just choose one of them. Then y is what? The larger. Now you could have, if you wanted to, used S and L. Okay, the problem with using S is it looks like a 5. Okay. Good, so look at the first one, the sum of two numbers. What should we write down for that one? X plus y equals 56 because the word sum means add. Good. The larger exceeds twice the smaller by 2. What's twice the smaller? 2x. The larger is y. What do you think they're talking about with exceeds? It means it's bigger. So if I take the larger one and I take away twice the smaller, what should it equal? 2. So y minus 2x equals 2. Now have a look here. Are our variables lined up? Nope. Could we line them up easily? Totally could. Looking at the top equation, we could easily switch x and y around. So we could go y plus x. That won't change anything. Then let's eliminate. Should we do adding or subtracting to eliminate the y's? Subtracting. Okay. Make sure you subtract carefully here. What's x minus 2x? Sabrina, what do you think? Plumber? 3x. Right? So you got to be careful with your signs. The minus negative 2x turns into an addition. Okay. Good. What does x equal? X equals 18. All right. So now you found one number. How are we going to find the other one? Do substitution again. I would substitute in the top one. That's easiest. Okay. So y plus x becomes y plus 18. And y equals 38. Okay. So we can answer the question now. Two numbers are 18 and 38. Put it in a box. There we go. Any questions so far? Okay, next one. Perimeter of a rectangular garden is 19. Let's draw that first, and it says find the dimensions of the garden. So what are we looking for dimensions? Dimensions of a rectangle would be length and width. Okay. So we could use X and L. If you're going to use X and L, you have to write down which is which. But what could be some better letters to use? L and W. Because then you don't have to worry about an if-then statement. So it makes it easier to use an appropriate letter like that. Okay. Notice for the rectangular garden, I drew the thing. Okay. Perimeter is the distance around the outside. Okay. So, how many lengths are there? If you're going all the way around, how many lengths are there? 2. How many widths are there? 2. So that is your perimeter. Okay. So your perimeter is always going to be this for a rectangle. And what should that equal? 19. Okay. Good. What's the next part? Triple the length. What is that going to be? 3 times L. Is half a meter longer. Is your equal sign. Now half a meter longer, that means that 3L is first. And you would subtract 5 times the width. What would 5 times the width be? 5W. So if you go 3 times L and minus 5W, what should it equal? Triple the length is half a meter longer than 5 times the width. So it should equal half a meter. All right. So let's do elimination here. Substitution would not work very well because we have coefficients in front of L and W. What should we multiply the top equation by? Sorry? 3? Why? Good. So what are you trying to get the same? The length. So the top one we're multiplying by 3, the bottom one we're multiplying by 2. There we go. So now we can eliminate the L's. Should we add or subtract? Caleb, what do you think? We have 6 and 6. How can we get to 0? Good job. Subtract. Okay. Be careful with your W's. How many W's do you think you have, Slater? Good job. Well done. Okay, so you're taking away a negative, which means you're really adding. Then go to your calculator. 56 divided by 16. The answer is 3.5. Does it make sense to have a decimal for a measurement of length or width? It does. Okay, so let's use that. Okay, go ahead, find your length. I'm going to use the top equation. And I'll substitute my W in. So, for your sentence, we'll just say width is 3.5 meters. Make sure you have your units. Length is 6 meters. There we go. Any questions? Okay. Very quiet out there. You guys okay with this stuff? Any questions at all? Catherine? Guys good? Okay. Okay, so next one, piggy bank one. This is classic. We have $4.55. That's in dollars. What's the value of a dime? 10 cents? What is the value of a dime in dollars, though? 0.10. What's the value of a quarter? 0.25. Now we don't have it, but what's the value of a nickel? 0.05. Is it EL or LE? EL? Okay, good. So nickel's 5 cents. Good. Okay, let's how many of each kind of coin are there? So what could we represent to represent how many dimes there are? What letter? D. So D equals the number of dimes. Then what can we use to represent quarters? Q. Q equals number of quarters. All right. Good. So, a question for you. You go into a store, you have 3 dimes. How much do you have? How did you figure that out? No, okay, so 3 times 0.10. What are those two things? Yep, thank you. What does 3 represent? The number of dimes. And we call that, there's a Q word for that, quantity. Okay. What's the 0.10? Value. Okay. So what we have here is we have value times the quantity. Okay. You're going to use that a lot. Value times quantity. So one equation would be the value of a dime times how many you have. And that's just like, you have 3 dimes, that's 30 cents, plus the value of a quarter times how many you have. If you walk into a store with 3 quarters, how much do you have? 75 cents. So you do it all the time. Now we just have to write it down with our math. And what was the total value of money that you had? $4.55. Okay. So this here is the equation in dollars. And we use dollars because $4.55 is in dollars. And I'm going to show you something what we can do a little bit later. Let's look at the next sentence. There are 23 coins together. So, what do we do? What's the equation for that? Yeah. We take the quantity of dimes we have, and we add the quantity of quarters we have, and that should equal 23. Right? So you got 20 dimes and 3 quarters. Yeah, that's 23. Okay. Good. So the first thing I like to do, and I'm going to show you a little trick here, is get rid of your decimal places. Because there's a decimal in front of both D and Q, it's easy to lose it. What can we do to get rid of all those decimals? Times it by what? 100. So then we would get 10D plus 25Q equals 455. What did we change that to now? We went from dollars into cents. You could start there if you wanted to. Absolutely, that's a good, valid starting point. But just make sure you don't combine them together and make a mistake. You either have to be all in dollars or all in cents. I've always, in fact, I've never taught this yet before, I've always started with dollars and made you do the conversion. Okay, but I think some of you are pretty bright in here. You might be able to do the conversion as you're making the equation. All right? Now, what should we do with the bottom equation to help us out? Times by 100, that wouldn't help at all, because then we'd have 100D and 100Q, and they wouldn't cancel. So what should we do to get them D and Q to cancel? Slater? Sure. Or what other number would work? 25. Good. Go ahead. Solve. Quick, quick, quick. It's a race now. Loser has push-ups. Let's go. I'm going to win. That means the whole class is going to have push-ups. I'm going to subtract. And then we get 15Q equals 225. And so I get Q equals 15. Oh, looks like I'm winning. You're going to have push-ups. Which equation will probably be the easiest to substitute into? Top or bottom? Top? No. Bottom one, right? There's no number in front of D and Q, no coefficients. So D plus 25, substitute in, equals 23. 15. Why'd you guys write 25? Like, seriously, I can't. Thanks, guys. Okay, D equals what? 8. Perfect. Quick little sentence. For dimes, the number of dimes equals 8. Number of quarters equals 15. Put it in a box. I mean, you could just say dimes equals 8, quarters equals 15. That's good enough. Okay. Okay. Now, stop. Don't. No. Stop. One thing that happens, if we had switched these equations, you would have got negative 15Q equals negative 225. Is that an error? Why isn't that an error? You would still get a positive number of quarters. It would be impossible for you to get negative 15 quarters. Yeah, unless you owed someone money. And that's weird, and really, it wouldn't make sense in the question. So watch out for that. Go back and check your work. Okay, next one. Go. Go. Next one. Hey, please read the question and come up with good variables. Make a little legend or if-then statement. Go. So what do you think would be a good if-then statement? What would be good variables? C equals what? C equals what? What's C? Cows? Are we talking about cows, Hammond? Oh, C represents chocolate bars. Okay, what other letter should we use? Yeah, I represents ice cream. So instead of doing if-then, sometimes I say do a legend. Just like a map. C equals chocolate bars. I equals ice cream cones. And it represents the number of chocolate bars. Okay, so this is your quantities. Nope, that's wrong. It's your value. Okay, it's the cost. So it's almost like we switched it around. Now we know how many we bought, but we don't know what their price was. So we'd still do cost times quantity. But we can switch it around and put quantity first. It doesn't matter. 3 times 4 or 4 times 3. Okay, so 4 chocolate bars, what would that be? 3 ice cream cones equals $5.30. Read the next sentence, do the next equation. Go. So you should get 2c plus I equals $2.20. Do you want to get rid of these decimals? Not really. You know why? Because you don't have decimals over on this side. So I wouldn't really worry about those ones. You could, but you don't need to. Okay? Good. Get your equations so that they can cancel out the c's. So get your c's the same. Okay, go ahead. It's a race now. Oh, well, she's working ahead. Good for her. Okay. I'll do them after school. You can come and watch. About 3 o'clock. Detention, small gym. Sorry. I is 90 cents for the ice cream cone. How much for the chocolate bar? 65 cents. Let's see if Pinto's right for a change. Okay, she's always right. No, not all the time, actually. Only when she does her homework, apparently. It's $1.30. Oh, you guys are paying attention. Okay, I want you to do something real quickly right now. In your calculator, I want you to type in 0.90 and then press equals. Oops, sorry. That's screwed up. 0.90. Why does this calculator do it? That's weird. Okay, so I'll do my point. My point is this. Last class we found C first, and then when we found I on our calculator, it equaled 0.9. Why would that? No, it's not. This is half a mark. Why? Yeah, you must be smart enough to know that we're dealing with money and we must have 2 decimals with our money. So it's kind of the same thing, but it's not worth a full mark. Okay? So be careful of that, especially when we're dealing with money for word problems. So we should write down now ice cream costs 90 cents, and you must have units. You can write that in cents if you want, but be careful. Chocolate bar costs 65 cents. Done. Okay. Any questions? All right. Okay, next one. Have a read. It's a little bit different. We're going to set up the equations. We won't solve. Good. What? You just keep staring at me. Read. When you join something and pay an initiation fee, how many times do you pay it? Once, and only once. That's important to know. Okay, so the initiation fee, you only pay once. That's the term initiation. Just ask senior boys basketball. Okay, so, oh yeah, who hasn't? Oh, I don't know. I didn't see it. Oh yeah, you're on that team, weren't you? No, we'll talk later. I'm recording right now. Okay, so initiation. That's a joke, by the way, Miss Hall. Okay, initiation fee, monthly fee. What would be some good variables to use? I equals initiation fee. Yes, you're right. Thanks for being M, oh, you're right too. Monthly fee. Thanks for helping me out here and keeping this interesting for me. Good. Okay. First month, member paid $260. Go ahead, write your equation. 1 month. What would you have to pay for 1 month? Hammond? Right. But what would you be paying? What's that $260 come from? Good job. So 1 initiation fee and 1 monthly fee equals $260. Good. And now what's the next one? At the end of 6 months, pay a total of $435. Wilson, how much? Well, I hope so. Otherwise, don't join any kind of fitness clubs or anything. Yeah, well, I'm not saying fitness clubs, but anything. Don't join anything, ever. You're going to get ripped off. Okay. So, how many initiation fees? How many monthly fees after 6 months? So, see what I mean? It's easy. Okay? But you got to actively do it, please. Okay? And that equals $435. Okay? Any questions about that? Okay, we're not going to solve. That's easy to solve. Next one. Person invested too large, $2,000. Part of it was only 8% interest. The rest was 10% interest. So after 1 year, and the reason why we have to say 1 year is because it takes a year to earn that interest, the total interest was $190. The last question will help us here. How much was invested at each rate? So that's what we have to do with our legend or our if-then statements. X should equal the amount at 8%. What would Y then equal? The amount at 10%. Okay. So look at the first sentence, make up an equation. Sorry, not even the first sentence, the first little part. This is just like our coins. So you have $2,000. That's made up of how much was invested at 8 and how much was invested at 10%. So X plus Y, the two amounts, add them up, must equal 2,000. Okay, so that's an amount equation. The next one is interest. We are told you make $190. So to make $190, you would take your interest rate, 8%. Oh, we can't use percent sign stuff. Good, 0.08. What about 10%? 0.10. So we're going to take 0.08 times that by X, the amount that was at that interest rate, and add 10% of the amount Y. Okay. What do you think the first thing is that we should do to make this easy for us? Times it by 100, which will get rid of our decimals. So 8x plus 10y equals 19000. Nothing wrong with that. Now it's so much easier. I find when you guys work with decimals, if you work with a lot of them, you tend to forget your decimal place and mess things up. What should we do with the first equation so that we can eliminate? Times it by 10 or 8? Are you guys confused? What should it be? 10? Who says 8? Who says 10? Does it matter? No. Both of them will work. Choose one of them. Hammond said, so I'm going to go 10. You said 8, I thought. No, never mind. Wait, 10x plus 10y equals 200, one more 0. I will subtract. I get negative 2x. Uh-oh, I think I did it wrong. Equals negative what? It's an extra 0. No, it's not an extra 0. You need that 0. Is that 1,000? Okay. Well, I got negative numbers. I guess I did it wrong. Why? Yeah, because I have to divide two negative numbers to get a positive final answer. Okay. Now I'm going to use the top one, x plus y equals 2,000. That's such an easy one to use. I think I'll pick that one. Put in 500. And most of you are like, why are you really doing that, Mr. Barker? Because I love showing my work. Okay. And so now you can say $500 at what percent? 8%. And look at my legend. My y is 10%. So $1,500 at 10%. You must specify which for which. Okay, you must specify. A lot of work.